My new topic is curve fitting. What is curve fitting? As it is pretty clear from its name, to fit the curve. So we have different ways to fit the curve in XY plane. We're gonna take on them one by one. But the very first method that we're gonna take is least squares method. In least squares method, we have different sub-methods. We're gonna solve least squares method in different ways. But let me first talk about what is least squares method. Why we call it least squares method. I'm gonna show you the first way to solve least squares method. Here is my table. This is my number n. Here is x. This is y. I have n, which is the number, x and y. X is the point along x-axis, y is the point along y-axis. N is any number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. X is the point along x-axis, and y is the point along y-axis. X and y are the coordinate points along x-axis and y-axis. Let me give you xy plane here. My very first point is at 1 along x-axis and 2 along y-axis. So in xy plane, its location will be here. It is on 1 along x-axis and 2 along y-axis. Similarly, my second point will be at 1.8 along x-axis and 3.3 along y-axis. So in xy plane, its coordinate point will be here. Similarly, my third point is at 2 along x-axis and 1.5 along y-axis. In xy plane, it lies here. My fourth point will be at 2.5 along x-axis and 2.5 along y-axis, which is here in xy plane. Fifth point is at 3 along x-axis and 4.4 along y-axis. Its location in xy plane is here. Sixth point is at 3.5 along x-axis and 2.7 along y-axis. So it lies here in xy plane. Seventh point is at 3.7 along x-axis and 3.8 along y-axis, which lies here. My eighth point is at 4.1 along x-axis and 5 along y-axis, which is here. My ninth point is at 4.3 along x-axis and 3.4 along y-axis, which is located here in xy plane. Similarly, my last point, which is 10th, is at 5.5 along x-axis and 5.4 along y-axis, which lies here in xy plane. Look, these are the points along x-axis, and these are the points along y-axis. So the very first point, my 1, which is this, is at 1 along x-axis, 1, 1 here, and 2 along y-axis, positive 2 along y-axis, positive 1, positive 2. So it is at positive 1 along x-axis and positive 2 along y-axis. Similarly, my second point, which is at 1.8 along x-axis, this is going to be my second point. This point is approximately 1.8, positive 1 and 0.8, 1.8 along x-axis and 3.3 along y-axis, 1, 2, 3. Somehow here, approximately 3.3 along y-axis. So 1.8 along x-axis and 3.3 along y-axis. Third point is at 2 along x-axis. This is going to be my third point. Positive 1, positive 2 here. And 1.5 along y-axis. Positive 1.5. Positive 1.5 along y-axis. And 2 along x-axis. Fourth point is 2.5 along x-axis and 2.5 along y-axis. This is going to be my fourth point, which is at 1, 2.5, 2.5 along x-axis and 1, 2.5, 2.5 along y-axis. This point. My fifth coordinate point is here, which is at 3 along x-axis, positive 1, positive 2, and positive 3. Positive 3 along x-axis and 4.4 along y-axis. 1, 2, 3, 4. 4.4 approximately it lies at 4.4. It is not the perfect match, but approximately you can say that this point is at 4.4 along y-axis, 4.4, and 3 along x-axis, 3, 1, 2, 3, 3 here. 6 point is at 3.5 along x-axis, 3.5, 1, 2, 3, 3.5 here, 3.5 along x-axis, and 2.7 along y-axis. 1, 2, 2.7, somehow here, 2.7 along y-axis. 7 point is at 3.7 along x-axis. 1, 2, 3, 3.7, somehow here, 3.7 along x-axis, and 3.8 along y-axis. 1, 2, 3, somehow here 3.8, this point is at 3.8, approximately 3.8 along y-axis, and approximately at 3.7 along x-axis, this point. This is my 7th point. My 8th point is at 4.1 along x-axis, 4.1, 1, 2, 3, 4. 4.1, somehow here, this is my 8th point. And 5 along y-axis, 1, 2, 3, 4, 5. 5 along x-axis. Similarly, my 9th point is at 4.3 along x-axis, 1, 2, 3, 4, 4.3, 4.3 along x-axis, and 3.4 along y-axis, 1, 2, 3, 3.4. This point is approximately at 3.4 along y-axis and approximately at 4.3 along x-axis. My last 10th point is at 5.5 along x-axis, 1, 2, 3, 4, 5. Somehow here 5.5, and 5.4 along y-axis, 1, 2, 3, 4, 5, 5.4 approximately here at 5.4 along y-axis and 5.5 along x-axis. So these were just simple coordinate points along x-axis and y-axis. Now in the next stage, what we're gonna do here, we're gonna fit the curve. We're gonna fit the curve between these points. We're gonna perfectly fit the curve with approximately equal distance on both the sides of the curve, like below the curve or above the curve. So let me first try some curves. If I try this curve here, it's a bit unfair because look, we have 1, 2, 3, 4. 1, 2, 3, 4. We have 4 points above this curve and 4 points below this curve. But when you compare these 4 points with these 4 points, this point is more away from the curve. It's a bit small. It is way near to this point, but it is way far. It is similarly far. It is also near. I cannot say that this curve is perfectly fit within these coordinate points, because somehow I can see that the distance of the points above the curve is more than the distance of the points below the curve. As I said, this is the approximation. This is not the perfect location of the coordinate points. These are the approximated coordinate points. But what I'm going to try, I'm going to fit the curve perfectly within these points, where I will try my best to have the approximated equal distance below the curve and above the curve. Or if the curve is in this direction, I will try my best to have the approximated equal distance on the right side and on the left side. But let me first try another curve. If you look to this curve, again it doesn't fit perfectly here, because look how many points I have below the curve. 1, 2, 3, 4, 5, 6. And how many points I have above the curve? 1, 2, 3, 4. So I will say that the distance below the curve is more than the distance above the curve, because I have more points below the curve than above the curve. So I will try my best My task is to fit the curve as perfectly as possible. I'm gonna try another curve here. It's pretty clear here that it's not a perfect match because we have more points on the right side than the left side. I have only 2 points on the left side of the curve, and I have more points on the right side of the curve. 1, 2, 3, 4, 5, 6, 7. This one you can say it is neutral because the curve crosses this point. So you have to look to the points without crossing by the curve. It's not the perfect fit. Let me try one more curve. What about this? Again, I won't say that it is a perfect match because look, I have many points on the right side of the curve and less points on the left side of the curve. So it's not a perfect match. But what if I try this point again? I won't say that it is a perfect fit because look, I have more points below the curve like 1, 2, 3, 4, 5 and less above the curve 1, 2, 3, 4. What about this? Again, it is not a perfect fit. Again, the curve doesn't fit perfectly within the points because I have more points below the curve and less points above the curve. So my task is to draw the curve equally between these points. I will try one more. What about this? It is somehow I can say that it is very near to the perfect fitting. In fact, it is not a perfect fit, but I must say that it is very near to the perfect fit. How many points I have above the curve? 1, 2, 3, 4, 5. And how many points I have below the curve? 1, 2, 3, 4, 5. 5 points below the curve, 5 points above the curve. This distance is very near, and similarly this distance is also near to the curve. I have no problem with this point above the curve and with this point below the curve. They are equally away from the curve. But somehow I have problem with the other points. When you look to this point compared to it, it is a bit more away from the curve compared to this. When you compare this point with this one, they're approximately equally away from the curve, but little bit I can say that this point is little bit away from the curve. But when you compare the second point below the curve with the point above the curve with this point, I must say that they are approximately equally away from the curve. But then when you compare the third point below the curve with this third point above the curve, there's a big difference. This point is more near to the curve compared to this point. It is away from the curve. Similarly, when you compare this point with the last one here, it's a bit near to the curve compared to this point. So I cannot say that it is a perfect fit, but I must say that approximately it is pretty near to the perfect fitting. So let me try one last curve here. This is my last curve. Now in my point of view, this is the perfect fit. This curve is perfectly fitted here. In fact, you can do more perfection than this. But in my point of view, this is a perfect fit. It's not a pure fitting, it is approximated perfect fitting. Approximated perfect fitting. You cannot say that it is very perfect, but approximately I can say that this is the best curve among the others. Because look, I have no issue with these 2 points here because the curve crosses these points. When you look to the other points, I have 4 points above the curve, 1, 2, 3, 4, and 4 points below the curve, 1, 2, 3, 4. When you compare this point with the point, there is not a big difference between the distance from this point up to the curve and from this point up to the curve. This is a bit near to the curve compared to this one, but when you compare this point with this one, it is more near compared to this one. Similarly, when you compare this point with this one, it is a bit far compared to this point. This point is a bit more near to the curve compared to this point. Similarly here, it is away from the curve compared to this one. Again, I repeat it. It is not the very perfect fit. It is the approximated fitting. It is more away from the point. It is a little bit away. It is more near to the point. It is more away. It's more away and it is a bit away. Let me take the vertical distance like the first point, distance number 1. and the second is distance number 2, distance 3, distance 4, distance 5, distance 6, distance 7, distance 8, distance 9, distance 10. Look, whenever you take the distance from the curve up to the points, you have to take it vertically. It must be a vertical distance. You cannot take distance in this way. There is a difference between the blue distance and the pink distance, because look, it is vertical. This blue distance is not vertically. Don't take the distance in this shape. As you can see in the blue shape, take it vertically all the way. Take the squares of all the distance and add them. Square of distance number 1 plus d sub 2 squared plus d sub 3 squared plus d sub 4 squared plus d sub 5 squared plus d sub 6 squared plus d sub 7 squared plus d sub 8 squared plus d sub 9 squared plus d sub 10 squared. So the summation of all the squared distances equals to capital D. Capital D is the distance. When you look to its name, least squares method, why we call it squares method? When you have to take the squares and the distance, like d sub 1 squared and d sub 2 squared and so on up to d sub 10 squared. Because of the square, we call it squares method. But what about the least squares? Least square means that when you add all these distances, if you get the least value, that would be the perfect match. The smaller you have the value for the D, the least value you have for the D, the perfect fit you're gonna have for the curve. Therefore, it is called least squares method. That when you add the squares of all the distance, and at the end, if you get the least value, that will be the perfect fit. The more perfect fitting you have for the curve, the least you will have the value for the D. That's why we call it least squares method. I hope it is clear now that why we call it least squares method. In the next stage, what we're going to do here, we're going to find the equation of the line, which is y equals to mx plus b. This is the one way to find the least squares method. We're going to do different ways to find the least squares method in upcoming lectures. But this is the very first method. In the very first method, my equation is y equals to mx plus b, where m is the slope of the line, b is the y-intercept. So to find the value of the m and b, I'm going to put one more column, which is x times y. Just take the product of x and y, you will get these values. As I said, so far we were doing that what is least squares method and why we call it least squares method. We got the concept up to this. Now in the next phase, we're going to find the equation y equals to mx plus b. We need to find the value of the m and we need to find the value for the b. For that reason, I'm going to put one extra column here, which is x times y. Just take the product of this x with a y. So 1 times 2 is 2. 1.8 times 3.3 is 5.94. 2 times 1.5 is 3. 2.5 times 2.5 is 6.25. 3 times 4.4 is 13.2. 3.5 times 2.7 is 9.45. 3.7 times 3.8 is 14.06. 4.1 times 5 is 20.5. 4.3 times 3.4 is 14.62. 5.5 times 5.4 is 29.7. Just take the product of x with the y. You will get these values. I'm going to add some more columns, like summation of x, which is 31.4. Summation of y, which is 34. Summation of x squared, which is 114.98. Summation of x times y is 118.72. Look, when you take the summation of all the x values, add all the x values, 1 plus 1.8 plus 2 plus 2.5 plus 3 plus 3.5 plus 3.7 plus 4.1 plus 4.3 plus 5.5 equals to 31.4. Just add all the x values. The sigma is for the summation. Summation of x is 31.4. Similarly, sigma y, which is the summation of y, add all the y values. add all these values, you will get 34. And then similarly, summation of x squares, sigma x square means that you take the squares of x values and then add them. Like 1 squared plus 1.8 squared plus 2 squared plus 2.5 squared plus 3 squared plus 3.5 squared plus 4.1 squared plus 4.3 squared plus 5.5 squared equals to 114.98. Remember, there is a square. First you have to take the square individually for the x, and then you have to add all those values. You will get 114.98. Similarly, sigma x times y, which is the summation of x times y. Summation of x times y. You have to add all these values, which is x times y. You will get 118.72. So the formula for the slope of the line will be n into sigma times y minus sigma x into sigma y, all over n into sigma x square minus sigma x to the whole square. Just substitute all these values in the equation. The formula for the b, which is the y-intercept, will be b equals to sigma y minus m into sigma x all over n. Let me substitute the values here. Look, n is the number of the points. This is my n. How many points I have? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my n is 10 here. What about sigma x times y? Sigma x times y is 118.78. Just plug in 118.78 for sigma x times y minus sigma x. Sigma x is 31.4. Plug in 31.4 for sigma x. Sigma y. Sigma y is 34. Plug in 34 for sigma y here. All over. And as I said is 10. And sigma x square. Sigma x square is 114.98. Plug in this value for the sigma x squared. Minus sigma x. Sigma x is 31.4. Plug in 31.4 for sigma x. And then its whole square. When you simplify this expression, at the end you will get 0.73. This is going to be the slope of the line. Now plug in the values for the b. Sigma y is 34. Plug in 34 for sigma y here. And minus m. What is m? M is 0.73. Plug in 0.73 for the m. Sigma x. Sigma x is 31.4. Plug in 31.4 for sigma x. All over. N. What is n? N is the number of points. How many points? 10. So all over 10. Simplify the expression. At the end you will get 1.108. This is going to be the y-intercept, which is b. So plug in the value of m and b in the equation. You will get y equals to 0.73x plus 1.108. That's how we got the equation of the line. Because look, my m, which is the slope of the line, is 0.73, which has been calculated from this formula. And b, which is the y-intercept, has been calculated from this formula, which is 1.108. Plug in 1.108 for the b. That's how we got the equation of the line. Look, my y-intercept is 1.108. When you go back to the graph, does the curve crosses the y-axis at 1.108? So let's check it out. Yes, this curve approximately crosses the y-axis at 1.108. It's not perfectly 1.108, but approximately this curve crosses the y-axis at 1.108. So my y-intercept is here at 1.108. That's all for the first way to find the least squares method.